In this video, I'm going to go over how to solve some polynomial inequalities. All right, a couple of these examples are going to be a little bit difficult, more challenging, but I know you guys can do it. And if you have any questions, just come in and we can go over them. All right, so this first example is to kind of get us thinking about how this is going to work. So they've already graphed y equals x squared plus 4x minus 5. And it's asking for what values of x is y equals 0. So that would be our x-intercepts, which would be here at -5 and here at +1. So the values for x would be x equals -5 or x equals +1. Excuse me. Excuse me. Okay. The next part. For what values of x is y greater than 0? So this is where you're looking for your y values to be positive, so they'd be above the x-axis. So if I highlight those parts there, that would be, this is above the x-axis, and same with over here. So that would be for x values that are less than -5 or x values that are greater than +1. And then it says for what values of x is y less than 0. So that's where you have negative y values, or below the x-axis would be this whole thing here. So that would be between, so between -5 and +1. Okay, so what we're going to do is, to find the solution without graphing it, we're going to first factor it. Okay, so I'm thinking of factors of -5 that add to +4. So we have x plus 5 and x minus 1. Okay, then I'm going to find my roots, and we're going to call these critical points. All right, so that's going to be x equals -5 and x equals +1. And we're going to break up this entire domain, right, of x values into little different segments here. So -infinity to -5 is our first interval. Then we're going to do -5 to +1, and then we'll do +1 to infinity. You're going to see that different things are happening depending on which side of the critical points you're looking at. All right. Then what I'm going to do is what is called a test point. So essentially, I'm going to plug a value in that's in between this interval, -infinity to -5 for an x value. And I'm going to see what sign, SIGN, that gives me to see if it's going to end up satisfying this idea that it's greater than 0. Okay? Now, you can choose any point. I always tell students to choose like the next one. So if you're moving from -5 to -infinity, the next point would be -6 would be an integer. So I'm going to do -6 plus 5. Notice I'm plugging it in to the factored version. It's much easier to do this when it's factored. Now again, I don't care about the number. I just care about what the sign is. So -6 plus 5 is a negative. -6 minus 1 is also a negative. So my sign is going to be a positive value. Okay, do the same thing for this one. Pick a test point. I'm going to choose 0. Wherever 0 ends up, I always choose 0. So 0 plus 5. And 0 minus 1. So 0 plus 5, that's a positive. 0 minus 1 is a negative. And so that's going to be a negative value. All right. This last interval is 1 to infinity. So I'm going to choose +2, which is going to be 2 plus 5 times 2 minus 1. So that's going to be a positive and a positive, which is a positive. So we're looking to see, where are my values going to be greater than 0, which is another way of saying positive. So I'm going to highlight where that's true. That's true in the first interval and in the last one. So where are the solutions to this inequality? They're from -infinity to -5, or from 1 to infinity, which, when I scroll back up to the graph, I think you'll see that that is where the y values were above the x-axis. Okay, now the only difference, if they had made this less than 0, would mean that this one, this negative, is what I would care about. And my answer would have been -5 to +1. All right, okay, so you'll see I've worked a couple examples here. Check out Canvas for this key. I want to do 5 and 6 with you guys. These I think are the most challenging ones. For this video, I think it's best to do the ones that are going to require probably the most questions. So here we go. Example 5. All right, first thing I notice is let's get it all to the same side. So the opposite of x squared plus 2x plus 15 is less than or equal to 0. All right, then I want to go ahead and factor out that -1, which leaves me x squared minus 2x minus 15. And then I want to get it to the other side. So I'm going to divide by a -1. Try that again. Divide by a -1. And when I divide it by both sides, hopefully you remember from middle school that we have to do change the inequality symbol when we do this. So it's going to be greater than or equal to still 0, because 0 divided by -1 is still 0. All right, so I'm going to factor this now, looking for factors of -15 to add to -2. That's going to be x minus 5 and x plus 3. Yes, that is good. All right, and then I'm going to find my roots or my critical points, which are going to be x equals 5 or x equals -3. All right, remember to go in order from least to greatest, right, left to right. So I've got -infinity to -3. Then we've got -3 to positive 5, and then 5 to positive infinity, okay? So my test point that I'll use for this first one is going to be -4. So I'm going to plug in -4 minus 5 times -4 plus 3. All right, let's find the sign of this. So negative minus a negative is still a negative. Then -4 plus 3 is still a negative, so the sign is a positive. I'm going to plug in 0 here in the middle one. You'll notice 0 is between those two numbers. So 0 minus 5 and 0 plus 3. So that's going to be a negative times a positive, which is a negative. And last but not least, I'm going to plug in 6. 6 minus 5 and 6 plus 3. This is going to give us both positive numbers. So the sign is positive. And I'm checking my sign here. It says greater than or equal to 0. So I'm going to highlight where it's greater than or equal to 0, which is the first one and the last one. Now keep in mind, it does say or equal to. So watch what happens when I write my answer. It's -infinity to -3, but we're going to include -3, right? Because -3 is one of our roots where it would make this become 0. And then the union of that would be from 5 to infinity. Again, 5 has a bracket around it because 5 also makes this become equal to 0. All right, so this is going to be the answer for example 5. All right, last one, example 6. Now this one is a cubic polynomial with 4 terms. And when I think about trying to factor it, I'm looking at possibly factoring by grouping, but I'm not going to be able to continue with that because I won't be able to get the same thing in terms of those parentheses. So this is not able to factor by grouping. So this leads me to using that rational zero or rational root theorem, which we talked about recently, to find some possible answers, possible roots that I'll use synthetic division to see if I can find any. All right, so I'm going to do factors of the constant. So that's 1, 2, 3, and 6, and then over the leading coefficient, which is 1. So these numbers divided by 1 will just be those numbers. So I'm going to try positive 1 and hope that I end up getting 0 when I finish this synthetic division. Let's see what happens. Okay, bring down the 1. That's not it. 1 times 1 is 1. Add, multiply, and then that is not going to be a root. Make sure my work is good. Okay, good. All right, so let's try -1. You got to keep going until you find 1. All right, so we have -1, that's 1, -1, this might be it. Yes, we got 1. Awesome. All right, so this right here is one of my roots. So I'm going to write x plus 1, right? Think opposite. And then using these coefficients at the end of my work right here, I can write down what's remaining, which is going to be x squared plus x minus 6. And this is still all greater than or equal to 0. I'm going to factor this trinomial to be x plus 3 and x minus 2. Should be good. Let's make sure. Yes, that's good. All right, so then my roots or my critical points are going to be x equals -1, -3, and +2. Okay, so I have a lot of, or an extra one here for my intervals. So -infinity to -3. Then I have -3 to -1, -1 to +2, and then 2 to +infinity. Plugging in my test point here, I'm going to do -4. Don't forget to go into the factors here. So -4 plus 1 times -4 plus 3 times -4 minus 2. All right, so the sign of this, we're going to have that's a negative times a negative times a negative. So that's 3 negatives. An odd number of negatives will still be a negative. All right, let's try -2 is in between those. So -2 plus 1, -2 plus 3, and -2 minus 2. That's going to be a negative times a positive times a negative. That's an even number of negatives, so that's going to be a positive. 0 is in this one, so here's my 0. 0 plus 1, 0 plus 3, 0 minus 2, so that's going to be positive, positive, and negative. That's an odd number of negatives, so that's negative. And last but not least, I'll do +3 here. 3 plus 1, 3 plus 3, 3 minus 2, and I believe that will all be positive. It will, so that's positive. And this one is, again, greater than or equal to 0. So I'm looking for my positives, which are these two. And we have or equal to, okay? So I'm going to put -3 in a bracket because it does equal 0 to -1, also in a bracket, that becomes 0. And then the union of that with +2 to infinity. Remember, infinity or -infinity will always have parentheses. Okay, guys, so that is it. All right, I've got the key on Canvas, so make sure to check that out and come to office hours, and good luck.